let's kick off this explainer. If you're working with infrastructure as code, Terraform on AWS is an absolute beast, but it can definitely feel a bit overwhelming sometimes, right? Well, let's completely shift our perspective today. I want you to think of it exactly like building a house. You've got to have land, your bricks and mortar, a way to customize the paint, and connections to the neighborhood grid. By the time we wrap up here, you're going to see exactly how all these pieces seamlessly snap together.
And to make sure we're building on a rock-solid foundation, we've pulled the absolute best insights from Bhanu Pratap Mahato's massive 711-question interview guide. We've done the heavy lifting, cutting through all the noise to bring you the exact actionable knowledge you need to get a real practical edge in your day-to-day cloud engineering.
Okay, let's dive into this. Here is our game plan for today. We're looking at 4 foundational blocks: configuring the AWS provider to establish our site, building with resource blocks to lay the bricks, using variables for dynamic design, and finally fetching data with sources to map out the neighborhood.
Let's jump right into Section 1, configuring the AWS provider. This is all about laying the groundwork and hiring the contractor.
You know, you can't just start throwing up walls. Before any actual building happens in the cloud, you've got to set up your environment and establish who is actually doing the heavy lifting. Which brings up a scenario that pops up a lot, both in interviews and in the real world. Say you're setting up your config, you authenticate, but you completely forget to tell Terraform where to build. What actually happens if you just don't specify an AWS region in your setup?
Well, the answer comes down to the provider block. Think of this block as your general contractor. It configures communication with the AWS API and handles all the authentication. And if you forget to give it a region, your contractor is pretty smart. It just gracefully falls back to the default region specified in your local AWS config. Or, if even that's missing, it defaults to US East 1. It makes sure your build always has a location.
But here's the thing. Handing over the keys to your contractor requires absolute trust. Security is going to be a huge theme for us today. Hard-coding your AWS access and secret keys directly into your Terraform files? Yeah, that is a massive security risk. Please don't do that. The source material really hammers home safe authentication methods. Instead, we're talking environment variables, shared credentials files, or, honestly, the best route, using IAM rules attached directly to your EC2 instances. Keep those keys out of your code. Nobody wants their AWS bill accidentally funding a crypto mining operation.
Now, occasionally, your contractor is going to need to update their tool belt. Upgrading the AWS provider is actually wonderfully simple. You just set your version constraints and then run Terraform Init-upgrade. That's literally it. Behind the scenes, Terraform automatically manages and updates the plugin for you. Super seamless maintenance.
Moving right along to Section 2, building with resource blocks. These are the literal bricks and mortar of your cloud house.
All right, the groundwork is laid, our provider is locked in. Now we're in the actual construction phase, turning abstract code into real functioning AWS infrastructure. But imagine this, you join a new team. They've got this incredibly critical EC2 instance running, but it was built manually in the AWS console ages ago. It's not in Terraform. You want to manage it with code now, but how do you modify this existing resource without accidentally wiping it out and causing a major outage? Talk about a panic-inducing scenario.
Resource blocks are your answer here. They define your individual components, your EC2 instances, your S3 buckets. But for our little panic scenario, the real magic trick is the Terraform import command. It is an absolute lifesaver. It lets you safely bring unmanaged existing resources right under the umbrella of your Terraform resource blocks without destroying a single thing. You're basically just adopting that existing infrastructure directly into your state file.
Now, what's really interesting about this slide is how Terraform handles scale. If you need 10 identical servers, you definitely don't write 10 separate resource blocks. You use meta arguments. But there's a highly nuanced technical difference you need to know here. Use the count argument when you just need a simple numeric volume of identical things. But if your resources need distinct identities, like, say, servers spread out across specific availability zones, you're going to want to use for each. That lets you loop through a map or a set of truly unique values.
And what happens when it's time to renovate? Terraform is honestly like the most careful construction crew ever. To avoid downtime during updates, it leverages resource lifecycles. So by default, or by explicitly setting options like create before destroy, Terraform will actually build your new infrastructure completely before it tears down the old stuff. It gives you a totally seamless rolling update with basically zero service interruption.
Let's step into Section 3, Dynamic design using variables. This is your customizable paint and furniture.
So, the walls are up, but nobody wants to live in a rigid, hard-coded concrete box, right? We need flexibility. When you start sharing your Terraform modules with other teams, they have to be able to input their own custom settings. But what if a specific database password or an instance type is absolutely critical for the build to even work? How do you ensure that crucial configuration value is never left blank by the user?
This is exactly what variables are for. They act as placeholders to parameterize your setup, which heavily reduces duplication and makes modifications super easy. And to solve our blank value problem, you just drop the required argument right into your variable block. If you define a variable without a default value, Terraform will literally stop the build in its tracks and demand the user provides one. No blank spaces allowed whatsoever.
It's also really important to map out how data actually flows through your cloud house. Input variables are how information gets passed into your configuration from the user, like picking the paint color. Output variables, on the flip side, are how your module exposes information back out, like handing the keys over to the homeowner. Outputs let your different modules talk to each other and share really crucial data, like an IP address that was generated during the build.
Let's bring back our security theme for a second. What about variables that hold API keys or passwords? The interview guide highlights this absolutely brilliant built-in mechanism. By just adding sensitive equals true inside your variable block, Terraform actively redacts that value from ever showing up in your command line logs. Combine that with your CI/CD secret management tools or secure environment variables, and your cloud house is locked up tight.
Finally, we're at Section 4, Fetching Data with Sources. This is where we read the blueprints of the existing neighborhood.
Look, your house doesn't exist in a vacuum. It needs to connect to the power grid, the water lines. In cloud terms, we often need to read the blueprints of the existing neighborhood infrastructure. Say you know the exact ID of the VPC you want to build inside. Why not just copy and paste that ID directly into your resource block? Why go through all the hassle of setting up a data source? Well, I want you to challenge yourself here and think about how incredibly dynamic the cloud really is.
So, the crucial point is this. Data sources give you read-only access to live, real-world information. Hard-coded IDs, they change, they get deleted, they differ entirely across dev and prod environments. But using a data source to dynamically look up an existing AWS resource, you're guaranteeing your code always uses up-to-date, accurate info without any risk of accidentally modifying it. The guide makes a really advanced technical distinction here that you absolutely should be aware of. Not all data sources act at the exact same moment. Think about this carefully. A static data source resolves immediately when Terraform first reads your configuration. It just grabs the info right up front. A dynamic data source, though, might depend on something else being built first, so it evaluates much later, during the actual resource creation phase. Honestly, understanding this timing difference will save you from so many frustrating dependency errors.
To make this totally concrete, here are the really common day-to-day use cases where you'll be reaching for a data source block. You're going to use them to fetch the latest, most secure AMI details for your EC2 instances. You'll use them to dynamically retrieve lists of available AWS regions. Getting subnet IDs based on VPC tags, data source. Discovering your RDS endpoints, data source. It's exactly what keeps your code truly modular.
And this quote right here brilliantly sums up the core philosophy we've been exploring. Pulling data dynamically ensures flexibility, consistency, and ease of maintenance. When you bring it all together, the land from your providers, the bricks from your resources, the paint from your variables, and the blueprints from your data sources, you're stepping entirely away from amateur scripting. You're building truly robust, professional-grade infrastructure.
We've officially laid the entire foundation. You know how to secure your provider, how to gracefully import and update resources, validate those dynamic variables, and securely query the live cloud environment. So with all these incredible tools now right at your fingertips, what are you going to build next? Open up that terminal, fire up Terraform, and go construct your cloud house. Thanks for hanging out with us for this explainer, and we'll see you next time.